Okay. Well, we have these three problems that I asked everybody to solve. People did reasonably well with these, okay? There's one trap that I set on this problem. One person avoided the trap, but everybody else fell into it. Okay. So we'll see what the trap is. So you have something to look forward to here in a couple of minutes. All right, now to solve any absolute value equation, you're going to break the equation eventually into two equations. Okay, so if we have absolute value of x plus 4 equals 9, this means that whatever's in these absolute value signs has to either be 9 or -9, right? Okay, otherwise its absolute value wouldn't be 9. Well, this says that x plus 4 equals -9, or x plus 4 equals 9. Now, I really want to see kind of this format. I don't care if you got these little lines there. If you got this down here, it's okay. But the little lines kind of reinforce for you the fact that this thing is splitting into two equations. So it's not a bad idea to include them. Well, now that we've split this into two equations, we can easily solve, and everybody solve them correctly. And of course, the intermediate step is subtract 4 from both sides here. So add 5 to subtract 4 from both sides here. And these are the solutions you get, and then we check. Okay, that's kind of an automatic part. Although if we're doing a quick quiz in class. Okay, well, the check is we substitute x and we know the absolute value of 9 is not. I didn't read all these steps, but this equation becomes this because we replace x by -13, and then we get absolute value of 9 equals 9, and that works out just fine. Okay. And its absolute value -9 equals 9. Is -13, so it is -9. If x equals 5, well, I'm just going to say, etc. We do the same thing and verify it, put a little check mark there. So we've validated both solutions, okay? And then we say, actually, I should have set it up here. So often you want to express the solution set, which is a set of numbers, -13 and 5, okay? So right there, this set of set brackets contains all of your solutions, okay? Okay, well, we can then look at the second equation, which is 2 times the absolute value of 3x minus 12 equals 2. We divide both sides by 2. Make sure that absolute value sign's pretty big. We don't read this as 13. We divide both sides by 2. We get 1, we don't write it in the denominator. And 2 divides 2. 2 is a factor of the numerator, so it can be divided by the denominator. And we get absolute value of 3x minus 12 equals 1. And that splits into 3x minus 12 equals -1. Or 3x minus 12 equals 1. And easy enough to solve. We get -13/3. Or x equals 11/3. Okay, well, we can check. Okay, this equal sign with an arrow on the end of it means that what I write here follows from what I've got here. If this is true, then this is going to be true. Well, what's this? This is going to be 2 times the absolute value of 3 times -13/3 minus 12 should equal 2. In other words, we just replace x here by this value, which means you have 2 times the absolute value. Well, you can think of this 3/1 times -13/3. 3 is a factor of the numerator, 3 is a factor of the denominator, so you can divide it out, and you get the wrong thing, because I wrote these solutions down too fast. Okay? So, yeah, I pretended to make a mistake, just so you can see how easy it is to do that. Okay, well, this should be 13/3, and this should be -11/3. So when I pretended to make a mistake, I made one that's easy to fix, just a couple little strokes like that. Okay? So we get 2 times the absolute value, well, of 13 minus 12 equals 2, which is 2 times the absolute value of 1 equals 2, which gives you 2 times 1 equals 2, and we're confident that that's correct. So that checks. Now, if you got the -11/3/13, you also need to check that, okay? But there it is. All right. So you see, just from the fact that I did something in my head and looked at it, must have been cross-eyed, got the wrong signs, you know, right? And that happened because I didn't do the intermediate steps. If I had carefully done the intermediate steps, I wouldn't have made the mistake. Well, let's move on to the last question. You know, let's say, y'all did pretty well at this. Okay. So I did very well. Okay. Now let's see what I'm talking about when I said I set a trap for you. And I'm not really trying to trap you, just trying to make a point. Okay, so we have 3x plus 6 greater than 5x minus 2. Okay. So I subtract 6 from both sides. I bring this side down here and do a -6. Bring this side down here and do a -6. Okay. And we get 3x greater than 5x minus 8. Then I write my 3x, I write my 5x minus 8, and I really want all my x's on this side. If you got all your x's on this side, it's equally valid. Okay, it's not incorrect. Then I really wanted to put them on this side so I could trap you. Okay, well, totally valid. One person left got the x's on this side, got the correct solution. So nothing wrong with that. Now the trap comes here. You see in a minute. First of all, we're going to have to subtract 5x here, I'm gonna have to subtract five x here. Five x minus five x is 0, that leaves us -8, and we have -2x. What do we do now? Well, what people did was they wrote down this. What's wrong with this? It's got to reverse. Okay? Because you're dividing by a negative. If you multiply or divide by a negative, that switches your inequality. It's not hard to understand why, but I'm not going to emphasize that. We've got a lot of stuff we need to cover tonight. Well, anyhow, it's got to be a less than. And now we get x less than 4. Then we sketch it on a number line. Okay, we have 4. And we have all values of x that are less than 4. And we indicate that by first indicating that 4 is not included. If it was a less than or equal, if this had been a greater than or equal sign, then this would have been a less than or equal sign. And 4 would have been included in the solution. But if x is 4, this is not going to be greater than this. They're going to be equal. Okay? Anyhow, here's our solution set. And we can kind of check this, and we can't check it for every number down here, but to check, just pick a number less than 4. Okay. Okay, somebody picked 3. Okay, so let's just say 3 is here. We plug that back in to the equation. I don't have a lot of room here, but I've got a little space there, so I'm going to put my check in here. Okay. Three is less than 4. And we get 3 times 3 plus 6 is greater than 5 times 3 minus 2. If this proves to be true, then we're pretty sure we have the right solution. Well, that gives us 9 plus 6 is greater than 15 minus 2, which tells us that 16 is greater than 13. That's true. So that much of the check works. Now you could check it for every number less than 4, but there are infinitely many numbers less than 4. So you can't possibly check it. Now to double check, you might let x equal like -1,000,000. Okay. If x is -1,000,000, then this side is pretty close to -3,000,000. Okay. And this side is pretty close to +5. Well, yeah, to -5,000,000. And -3,000,000 is greater than -5,000,000. -3,000,000 would be to the right on the number line of -5,000,000. I just think if x is a really big number and it's negative, well, think about it. Okay, so y'all did well in the homework. And anywhere from well to very well, and you did well on the quiz. A couple of you missed this reversal of the sign, so make sure you got that straight. Okay, and check it. If you check it, you're going to find that it doesn't work. If you thought x was greater than 4, we'll plug in 5. Okay. Yeah, that gives you 15 plus 6 is 21. It gives you 25 minus 2, which is 23. 21 is not greater than 23, so you'd end up with an incorrect solution. And then you'd go, oh, duh, I had to reverse that sign. Pretty soon you get used to it. Okay. I admit, in a hurry, when I was first learning. And algebra 1 or algebra 2, when I was first learning this stuff, I slipped up on that a couple times. And then I caught myself, went back and fixed it, okay? I think, at least that's story's been handed down for generations. Probably kept making the mistake for a couple of days until I got it straight. And now I don't see any way to pause. There we go. Okay, we're going to talk about coordinate plane. Something you're familiar with. If we're going to draw a coordinate plane like this, now I was going to make a copy. And then I want you to divide it up the way I do. I want to put 8 here. And I'm going to put -8 here. And I'm going to put 8 up here. And I'm going to put -8 down here. Okay. Now, you can do that. I'll give you a minute to do what I'm doing here. Then, watch carefully. I'm going to divide the interval from 0 to 8 in half. That'll give me 4. So that's 4, and there's 4 more there. I didn't do it perfectly. I was a little too far to the right, but I try to do it as well as I can. And then I divide this interval in half to get 4, and divide this interval in half, label this 4, and divide this interval in half and label this -4. Okay, can you do that? Okay, well, everybody did a good job of that. Now, what I want you to do is I want you to take the interval from middle to 4, from 0 to 4, cut that in half. Okay, and then cut all these other intervals in half. Okay, just do the same thing over here, doing the same thing here, 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 and here. Okay, so, well, we can do that. Let's see, actually, I left one off. I didn't cut that one in half. Okay, now that's what you should have had. And then you cut every one of these intervals in half. Okay. Now, this is your x-axis and this is your y-axis. I'm just going to throw out a question here that in a pre-calculus class for sure, I wouldn't expect many people to answer correctly at the beginning of the course, okay? I just want to see if anybody, I'm just kind of gauging a little bit about what you know. I don't necessarily expect you to be able to answer this question. If you can, it'd be great, okay? If you can't, well, that's kind of what you expect. Okay. Can you draw the line x equals 3? The line x equals 3 consists of all the points whose x coordinate is 3. Can you draw 2 points whose x coordinate is 3? Just see if you know what I mean by x coordinate. And if not, okay, well, let's just say there's some of you are looking a little blank on this. As a matter of fact, nobody's looking like they really feel like they understand what I just asked, but maybe you do. So let's modify my question. Is can you plot the points 3, 4, and 3, -2? If not, that's okay. I'll explain it in a minute. Well, that was good. Almost instantly when I walked back, I saw points on people's graphs, up to 4 of them. And they were all right above or below the point where x equals 3. Of course, everybody knows that x equals 3 right there. That wasn't a problem. So, I'm just gauging how fast I can go through this, okay? Just step by step. I can stop and do more explanation, but it looks like I don't need it. So, a point of, well, any point, it turns out, on this line has x coordinate 3, right? So this is the line, x equals 3 right here. I use a dotted line, but if you use a solid line, that's okay. Okay. Now, how about the line? Y equals 6. Okay, well, the line y equals 6, I mean, 6 is going to be right here, whether you've labeled or not. 4 is here and 8's here, and you should know that 6 is halfway between 4 and 8. Okay? So here's the line. Y equals 6. All right. Well, that's pretty straightforward. What are the coordinates of this point? Label the coordinates of this point. Just put parentheses, put the coordinates, and put a little arrow to that point. And what two lines intersect at -5, 2? Then can you sketch the lines and label the point? Okay, as I expected, everybody got it. Now, when I say the line through the two lines, remember lines are infinite, so they kind of go forever. Okay. So the way I'm going to draw the line here, well, here's x equals -5, and everybody understands that -5 there is the x coordinate, because you've done stuff like this before. Probably without the precision, and probably where somebody gave you a printout where everything was all lined off in a grid. I don't think it's a good idea to do that, because you don't make people construct their own graph. Okay, you're just putting points in a grid. When you do open math, you're gonna put points on a graph with a mouse or a trackpad or whatever. Okay, you're gonna click me, put points there. I think you understand it more deeply if you draw the thing out. Okay, and when you do the homework, I recommend, don't require, but I recommend that you write it out in your notebook. Keep your notebook so I can look at it. Okay, and if you haven't, well, as long as you can do well on the tests, whatever you're doing is working, right? And if it works, I'm happy with it. Okay. Anyhow, this is the line. Can we label the line? X equals -5. Okay, I don't necessarily put the word line there. We understand that it's a line and I'm labeling it. Okay, and the line y equals 2. And then we mark the point. And we mark the point. This point is 3, 6. And this point is -5, 2, kind of bunch that up a little bit. Okay. Okay, now. Can you draw the straight line through those 2 points? Sketch a straight line through the 2 points. Okay, I wish I had time to figure out why people didn't quite understand my instruction, but everybody, as soon as I pointed out, everybody knew immediately what I was talking about, okay? If I'd have drawn it for you, that would have been good, but of course, we're trying to learn to follow instructions as well. So what I'm gonna do is I'm gonna say, okay, well, the line kind of goes this way, right? Got a line through these 2 points. Well, I mean, if I had a straight edge, all kinds of straight edges lying around. Okay, the line's gonna be there. I could draw it with a straight edge. Okay. Then we don't want to take the time, to pull out drafting tool every time we want to draw a graph. So we want to learn to sketch these things, and everybody's sketching. Everybody's sketching ability looks up to the task. Okay, everybody seems to be doing fine that way. Now, let me give you a hint as to how you do a line through 2 points. Okay, how you draw it. Okay, at this point, you know, kind of watch what I'm doing here, because this is, okay, right up and right. So, what you tune into what I'm showing you, it'll save you some trouble and make your pictures better. Okay, so I've got a point here and a point here, and if I follow this pattern, I think the line should go through there. Okay, I think that's pretty well lined up. Of course, I get down here and look at it. And now I'm going to start here. And I'm not going to look at this point. I'm just going to look at this point. If I look at this point, I'll hit it. More or less. Okay. So if you want to hit a point, you want to draw a line, figure where to start it, and then look at the point you're aiming at. Okay. It's works for almost everybody. And if you do it a couple times, you get good at it. Okay, so there's a line. Okay, now there's a formula or an equation that goes along with this line. First of all, we want to find the slope of the line. That's the question before I turn this off. If I say the word slope, does something come to mind? Okay, what is it that you associate with the word slope? Okay, so I get asked about slope as, you know, words that came along with people. Well, you know, intercept was the first word I heard. Well, yeah, that's a good word because we're looking for the slope intercept form of this line, which incidentally is, I'll write it down here. That's y equals mx plus b, where m is the slope and b is the y-intercept. Okay. Now, the way I drew this, and I don't think it's going to be correct, but the way I drew this, it looks like the y-intercept is 4, doesn't it? Okay, just since the word intercept came up, the y-intercept is the coordinate or the point where the graph passes through the y-axis. It looks like it hits it pretty close to 4. Matter of fact, it looks like a pretty much nailed 4. You know, it was a little low going through this point, a little high going through this point. If I tilt it, it still goes through 4. Okay. Now, slope. Somebody said up. Okay. If you got a slope, you can go up or you can go down, right? And kind of weather we had a couple of weeks ago, you know, people sled down the slope. Okay, steeper the slope, the faster you go, more likely you get killed. Okay, and that's of course the attraction for most young kids. My grandson, when he was small, it went down the slope in front of our house, and there's several ledges and groundhog holes and big walnut trees. So you got this 5-year-old kid on a sled going about 80 miles an hour, weaving between the trees, hitting the groundhog hole, bouncing in a way that would have killed me. And this was 15 years ago, okay? It would have killed me then, you know, it would have, you know, just thinking about it would kill me now. Yeah, slopes are great things. Okay, well, that's a total digression, but I want to get the idea of a slope as being steeper or less steep, okay? That's kind of the way why I chose to let myself digress there. And there are no walnut trees here, so that's okay. So to find the slope, anybody ever hear of a rise? You ever associate that word with a graph, a rise or a run? Okay, rise and run. Okay, so you most are nodding, some are nodding more vigorously than others. Okay, but you know, what's the rise and what's the run? Because that's what you use to calculate the slope. You just divide the rise by the run. Okay, well, I'm going to draw a triangle. Okay, and I'm going to put arrows on it. The triangle is going to start at the left and go to the right. Well, I can draw an arrow this way, but I can also draw arrows on these two legs that give me the same path. The path from this point to this point. Okay. Now, if I give you any 2 points on the graph, one's going to be higher than the other usually. Okay. So you don't, you know, if the second point, the point to the right is lower, then you're going to have to go down and over, right? Okay. So you go up and over here. You go down and over here. Okay. Or up and to the right, down and to the right. In this case, you go up and to the right. Okay. How far do you have to go up? Now, there are 2 ways to see how far you're going up. First place, these are horizontal lines, y equals 2 and y equals 6, right? Your first point's on the y equals 2 line, your second point's on the y equals 6 line. How far is it from the y equals 2 line to the y equals 6 line? Well, it's clearly 4. Okay. Okay. And of course, you can get that. There's a formula, and a lot of people remember the formula, but don't remember what it means. I don't even like the formula. Okay. Formula is okay if you first learn what it means. If you subtract the y coordinate here from the y coordinate here, you get 4, right? So you just take this y coordinate minus this one, and it'll give you the 4. But you want the picture. Now, if the numbers are obnoxious, you know, 3.8725 and 14.9386, okay? First place, you can't just see what the number is. You're going to subtract it. You can probably use a calculator, okay? No reason to do it any other way. So you got to know what to do. You got to know that if you do this one minus this one, it's going to give you the rise. Okay. Well, the rise goes from 2 to 6. The rise is 6 minus 2 equals 4. And right there's your rise. Okay. Now the run is how far you go to the right. Or if you happen to be going to the left for some reason to get from one point to the other, well, you have a negative run. But usually we're going to go from left to right. So what's the run? How far do you have to go left to right to get from this point to this point? You can show me with your fingers. Don't say it because we've got the camera going on. Actually, I'll pause the camera and let you take a good look and think about it. Okay, so the run is how far you have to go from here to here. How far you have to go right along this part of the triangle. I don't have a good place to label this. So I'm just going to say the run equals 3 minus -5 equals 8. Okay, so there's the run. Now I can draw a bigger picture of this triangle. And I don't like where I'm drawing that, so give me a second. Need a little more room to the left. I can label some things. Okay, so here's my triangle. Okay. You take this x coordinate and subtract this x coordinate, you're going to get 3 minus -5, which of course is 3 plus 5, which is 8. Now you can see here that it's 5 here and 3 here. That makes sense, right? You go from here to here. The distance between this vertical line and this vertical line is 8 units. You can count. If you can't count, you just got the coordinates. That's how you get it. But that's why the run is x coordinate where you're going minus the x coordinate where you start. There's a formula for that. But people use the formula and forget the picture. We want to have the picture. So the rise is 6 minus 2 equals 4. A little circle around that. Okay, well, now the slope is rise divided by run, which is 8 divided by 4. Oh. My eye caught that 8 up there, and my brain wasn't engaged when it did, so I wrote it down. Okay, let's try to get it right. Rise over run is rise is 4. The run is 8, and of course, that's 1/2. Okay. So somewhere outside the triangle, next to this, the hypotenuse of the triangle, the part of the triangle that coincides with the graph. The convention I use, and I want you to use, it's not a universal convention, so you don't need to use it if you're in another class. But I put the 1/2 here in a box. So I see my rise, my run, and my slope as soon as I look at the triangle. I don't have to look out here to see how I calculated the slope. I don't have to see how I calculated the run or the rise, although I want to have all that information there so I can check myself. But the important thing is the rise, the run, and the slope. So make sure those things are prominently displayed on a picture of the tribe. If I've got room down here, I do that. I don't have room to write all that stuff in, but I do have room to put my 1/2 in a box. And if I know the convention, I know that's the slope of this line. Okay, well, now we're close to getting the equation of this line, aren't we? The equation line is y equals mx plus b, where m is the slope. And b is the y-intercept. Okay, now. We see that the y-intercept is close to 4 because here's the y-intercept. Don't have a good place to label that. I should have made a bigger graph, and so should you. Okay, if you're graphing these things and drawing this, which I'm going to ask you to do next time. Ask you a very similar problem because I really want you to focus on what this information is and the information that goes into getting the equation of a straight line. But there's the y-intercept. I'll say it's at the 0.04. And then I'll contrive to have some sort of a arrow pointing at it. It's not exactly 4, just even if it looks like exactly 4 in your graph, because you can't use a hand-drawn graph to get anything exact, right? But you get a good idea. If you've done a good job on the graph, that y-intercept should be close to 4. So the equation should be approximately y equals 1/2 x plus 4. Okay, so okay. Does this equation give us a line through 3, 6 and -2, 5? Turns out it won't, because we're basing this y-intercept on our graph. Notice one thing, my vertical line here through x equals 4, it's pretty vertical here, but it kind of cheats in this direction over here. It's possible that I didn't divide this up with completely evenly when I drew the graph. Now, the reason we divided up the graph the way we did is it gives us a pretty even subdivision. My intervals are pretty close to being equal, okay? Every unit is about as big as every other unit, but it's not perfect. And this line wasn't perfect. It wasn't quite vertical. The point should have been a little further over here. That would have raised up my y-intercept a little bit. And I'm not all that sure about some other things in this graph, okay? Now we're gonna see that this doesn't work. We let x equal 3 and find y. Well, I'm gonna give you just a minute. Don't sit there copying because we don't have much time. You copy after we're done. But what I want you to do is let x equal 3 and see what you get for y. Plug in 3 for x. What do you get for y? Do you get 6? Okay, as I expected, people did pretty well with this, okay? We get y. Y equals 1/2 x plus 4. If x equals 3, y is 1/2 of 3 plus 4. So that equals 3/2 plus 4. If you want to do it as a decimal, it's 1.5 plus 4. One way or another, however you figure this out, it's 5.5. So we get to 0.3, 5.5. I'll do it for you. If x equals -5, yeah, I don't have room to write my point. I'll write it small here, but carefully. -5. One and a half. So it's not exactly this line. The line y equals 1/2 x plus 4 actually is a little lower here and a little lower here, which means that our y-intercept wasn't quite right. Should have been maybe a little more than 4. Okay. Well, that's a whole lot about straight line. Hopefully this exercise has prompted you so that you'll be able to do the open math assignments. I'm going to take a close look at the open math assignments, make sure they're reasonable. Okay, but you all know how to plot points. That's not going to give you any trouble. There are 3 sections due. No, actually, yeah, there are only 2. Okay. The 2 sections that are due, I don't think you'll have any trouble with. The third one is due a day earlier than it should be, but I'll adjust that. Okay. It was due like Monday night, when class is Monday, so.